take a look at the second page of our 2.6 notes from today. The first type of parent graph that we're going to talk about in this video is the quadratic graph, which has the equation y equals x squared. Now, before we answer any of these problems or questions regarding domain and range and so on, I am going to go ahead and graph this quadratic parent function and pick 5 values for x to plug in, so I have 5 points to graph. When I plug in -2 into x squared, I get 4. When I square -1, I get 1. When I square 0, I get 0. And when I square 1 and 2, I respectively get 1 and 4 for y. So these 5 points are what I'm going to graph to help us answer these questions to the right. So the general shape of a quadratic is U-shaped. The domain of my quadratic graph is all real numbers. I can plug in any value for x I want, and if you look at the graph, it goes forever to the right, forever to the left. However, the range is not all real numbers. The lowest y value I have on this parent quadratic graph is 0. The highest y value I can get is infinity, because it goes up forever. In class today, we talked about how to test for even and odd or neither functions. And we always plugged in -x for x. So I'm going to test the same way we did in class. I'm going to plug in -x for all the x's and simplify. And when we square a negative, it goes positive. Because we ended up with the same equation we originally started with, this is going to be an even function. And even functions are symmetric with respect to the y-axis. I only have one intercept on this graph, and that's the point 0, 0, and it's where our graph touches both the x and the y-axis. We also have a relative min at that intercept, so it is the lowest point on our graph. If we start at the left of our graph and work towards the right, my function is decreasing, and it's decreasing over the domain of -infinity to 0. So I am using the x values to write my increasing and decreasing functions. Right at this relative min, it turns around and starts to increase. And it's increasing over the domain or x values of 0 to infinity. Pause this video. If you need more time to write this down, hit play when you're ready. Cubic functions. Cubic functions have the equation y equals x cubed. And we're going to label 3 points on our graph to help us answer the questions to the right. So I'm going to pick 3 x values and plug them in to get my y values. Remember, when I cube a negative, that's like doing -1 times -1 times -1. The reason I'm showing this to you is your sign does not change, it stays negative. When I plug in 0, I get 0. When I cube the number 1, I get 1. So those are the 3 points on my graph that I am going to plot. The shape of a cubic function looks like that. Now the domain of a cubic function is all real numbers. And the range of my parent cubic function is also all real numbers. I'm going to perform the same test as before and plug in -x for x to see if it's even, odd, or neither. When I plug in -x and I simplify, I started with y equals positive x cubed, but now that entire term changed signs, so this is an odd function. And odd functions are symmetric with respect to the origin. I also have an intercept at 0, 0. This function, if I go from the left and trace it towards the right, my function is never decreasing. It is actually increasing over its entire domain. The third graph I want to talk about is the cube root function. And the parent equation for a cube root function is just the cube root of x. And I am again required to label or plot 3 points on my graph. And I'm going to pick the same ones I've kind of been sticking with, -1, 0, and 1. When I take the cube root of -1, I still get -1. When I take the cube root of 0, I get 0. And the cube root of 1, I get 1. Now those points that we just plugged in to plot look really similar to the ones in the cubic function. So let's make sure it doesn't look the same by just picking another value for x to plug in. Now the reason I'm choosing to plug in 8 is because I can nicely take the cube root of 8 to get 2. So this graph isn't increasing as fast as the other one is. It's just increasing at a slower rate. I still have the domain and range of all real numbers. In this function, when I plug in -x or x to test if it's even, odd, or neither, when I take the cube root of a negative, it does not go positive, it stays negative. So it's the opposite sign of what we started with, so this is an odd function, which is symmetric with respect to the origin. The intercept is the point 0, 0. And just like our cubic graph from before, it's not decreasing, it's increasing over the entire domain. If you need a moment to finish copying this down, pause the video and hit play when you're ready. So we're on the last page of parent graphs. The fourth one we're going to talk about for parent graphs is the square root function. And the equation for the parent graph is y equals the square root of x. And again, we're going to pick 3 points to plug in for x so we can plot them on our graph. And I am going to pick perfect squares so I don't have to use my calculator. So for example, the square root of 0 is 0. The square root of 1 is 1. Square root of 4 is 2. So I picked nice perfect squares to plug in to make graphing a little bit easier. Now if we look at the domain of my square root function, the lowest x value I have is 0. And the largest x value I can get is infinity. Now again, for the range, I need to think. The lowest y value I can get is 0. Because this graph is continuing to increase, that means my range is going to go up to infinity. Now for the zeros, I can also call zeros intercepts. My intercepts or zeros are at 0, 0. And this function is not decreasing because when I start at the left and go to the right, it is increasing from 0 to infinity. Reciprocal function. The equation of the parent graph for a reciprocal function is 1 over x. And they are asking us to label 6 points on the graph. So I'm going to pick the points. Let's go with -2, -1, 0, 1, 2, 3. So I have 6 points. So when I plug in -2, I get -1/2. When I plug in the point -1, my y value is -1. When I try to plug in 0 though, I get an undefined number. So I actually don't have a point where the x-coordinate is 0. So I might have to pick another point to plug in. When I plug in 1, I have 1 over 1, which is 1. When I plug in 2, I get +1/2. When I plug in 3, I get +1/3. Let's also, since I couldn't plug in 0, I have to pick another point let's say I choose to plug in for x -1/2. Well, when I do 1 over -1/2, I get -2 for my y value. So my graph is never going to touch the y-axis because it can never have a y value of 0. So I actually have an asymptote at x equals 0. So it's never going to touch that line. It's also never going to touch this other red horizontal line, which is y equals 0. It will never touch those two red dotted lines. The reason why it will never touch the line y equals 0 is it doesn't matter what value you plug in for x, your function will never equal 0. Because the numerator is staying a constant of 1, what makes a fraction 0 is when you have 0 in the numerator, which that can't happen because that 1 is up there. So the domain of my graph is -∞ to 0, but not including 0. My range is from -∞ to 0, but not including 0. So I also have from 0 to infinity. When I test to see if this is even, odd, or neither, and I plug in -x or x, I get my function to be of opposite sign, so it is odd, which is symmetric with respect to the origin. I don't have any intercepts because it never touches the x or y axis. And for this graph, when I see if it's increasing or decreasing, I'm going to start at the left and go to the right. So this blue portion I've drawn in or traced is decreasing. So we know it's decreasing from an x value of -∞ to an x value of 0. But then when I go ahead and trace from left to right of this piece in quadrant 1, it is also decreasing from 0 to infinity. So our graph is never increasing over the domain. The last graph is the absolute value function, and it has the equation y equals absolute value of x. So the parent graph for an absolute value function. In order to figure out what that looks like, I do need to plug in some values for x to get my y. When I take the absolute value of -2, I get +2. Absolute value of -1 is 1. Absolute value of 0 is 0. And the absolute value of a positive number is that same positive number. So my graph is going to be V-shaped. So the shape of an absolute value function is V-shaped. The domain is all real numbers. And my range is only from 0 to infinity. To test for even, to see if it's an even, odd, or neither function, I need to plug in -x for x. And when I plug in -x, the absolute value of a negative always goes positive. So because I end up with the exact same equation I started with in the beginning, this is an even function, so it is symmetric with respect to the y-axis. Its only intercept is at 0, 0. And this one does have a relative min, so a low point at 0, 0. And our graph is decreasing from -∞ to 0 when I go from left to right, and it is increasing from 0 to infinity over the domain. Please finish copying down the rest of the notes. Come tomorrow to class with questions, and we'll go over whatever questions you have about this portion of the notes.